let's work on something together. Let's try to see a specific problem. Assume that you have the log with base 9 of 81. Now, we know that the log of with base 9 of 81, since the 81 is nothing else than 9 squared, is going to be equal to 2, right? Okay. Now, take the following. Log with base 3 of 81 divided by the log with base 3 of 9. What's the result? Well, log with base 3 of 81 is log with base 3 of 3 to the 4th divided by log with base 3 of 3 squared. So this is going to be 4, log of 3 to the 4th is 4, and log of 3 squared is 2. So it's going to be nothing else than 4 divided by 2, that is equal to 2. Now I want you to focus on the numbers here, 2 and 2. I calculated the log of 81 here with base 9, and I calculated the fraction of log with base 3 of 81 divided by the log of base 3 of 9. In both answers are 2. Okay, let's see something different. Log with base 4 of 32. This is going to, of 64, sorry, of 64. Let's try this. 64 is 4 to the 3rd, so this is going to be the number 3. Now, let me do the following. Log with base 2 of 64 divided by log with base 2 of 4. This is 2 to the 6th, log with base 2 of 2 to the 6th divided by log with base 2 of 2 squared. That is equal to 6 divided by 2. That is 3. Okay, let's see. It's not a coincidence that I'm giving you to do the following problem right here. What do? I choose a number 3, let's say, right here. And when I have a log of a specific number on a base, the number 9, then what I do is that I take the fraction of the logarithm of the number that I start with divided by the logarithm of the previous base of this base with the new number that I chose, the number 3. The results happen to be the same, and I can assure you that this is not a coincidence. This is where we base the rule that says that whenever you want to change the base of a logarithm, so if you have the log with base a of number x, and you want to change that and find the log with base b, you want to change the logarithm base to base b, then this is going to be the same as log with the new base of x divided by the log with the new base of the old base a. And this is a rule. This is actually the 4th rule of logarithms. And why do we care? Why do we care to do something quite complicated as this? Well, I'll tell you right now why we care, and let me open the calculator for you. Let's look at this calculator together. That is quite advanced calculator, much more advanced than other calculators. Let's observe right here. Do you see any log? Yes, you do. 1. What is the base of this log? The base of this log is 10. And that's it. Do you see any other logarithm? No. Okay, let me go to to more tabs here. Do you see any log here? Well, you do. There is the ln. the logarithm with base e, the natural number. Do you see any other logarithm? No. Is there any way that you can find other logarithms in your calculator? Any calculator? No. The only logarithms that your calculator have is the ln and the log of 10 with base 10. So if I want to find the logarithm, let's say of 6 with base 2, I cannot find it. I can find the logarithm of 6 with base 10 is 0.77. I can find the log of 6 with, let's say, ln, the natural logarithm with base e, it's 1.79, but I cannot find the logarithm of 6 with base 2. Let me write it here so you can see what we cannot find. The log with base 2 of 6. This is something that you cannot find as is in your calculator. Well, so we need a way, a translation formula that can help us calculate this logarithm. And the formula that you will be using is what I show you right here. This formula right here is the formula that allows us to go from one base to another. So in our case, and I'll write it right here, I want to calculate the log with base 2 of 6. So my a is 2 and my x is 6. If I use this formula in order to calculate that, let's say with a log with base 10, so I will change my b to be the number 10 right here, then I can write the log of 6. Let me write the 10 right here just so you remember what is the base, divided by the log with the base 10 of 2. Am I allowed to do that? Yes, that's the whole point. This is the rule of changing bases. And that's the point of this rule, in order to be able to use our calculators. Now, can I calculate this number, the numerator? Yes, I can. Can I calculate the denominator? Yes, I can. Okay, let's do it. Let's calculate the numerator first. Log, what I want to calculate is log with base 10 of 6. So I change that to log with base 10, 6. Log is 0.77. Is this my answer? No. What I want to find is the log with base 2 of 6. So 0.77 plus some digit right here is the log with base 10 of 6. Now, if I continue and I find the corresponding denominator for the change of log, I will find the log of 2 with base 10. And this is 0.30. So I write right here 0.30. And the result for this is going to be, well, 0.77 divided by 0.3. My answer is 2.56. 2.56, this is the answer. Now, let's check it out to see, am I right? Well, look at the number. You have right here the log with base 2 of 6. The log with base 2 of 6. What do I know? The log with base 2 of 4 is equal to 2. The log with base 2 of 8 is equal to 3. So this means that this log, since 6 is in between 4 and 8, this means that the log with base 2 of 6 will be somewhere in here, in between the number 2 and 3. And that's true. I just found it. I just found the actual logarithm. I didn't approximate it. I found the actual number. It's 2.566. So that's why this formula that I just showed you right here is so important. That's why it has its own name, and it is called, after all, a rule of logarithms that is called the rule of changing bases on logarithms. Okay, so now what we want to do is continue and work with these problems work with some examples in order to make sure that we know exactly how to apply it every time. Let's work on more problems right here. Okay, assume that what you want is to calculate the log with base 2 of 5. Well, I have to say that I particularly like the log of 10 because I need to write less, so I don't need to write my my base here. I'll write it only for you. Remember, this is not supposed to be written. So log with base 10, log of base 2 of 5, I will apply the formula, the rule of changing bases. My x is 5, so I will put here x5. This is log of the new base, that's going to be the 10. So I want to calculate this. This is going to be log with base 10 of 5 divided by log with base 10 of the old base. So remember, at the denominator you have the log of the new base, the log of the old base with the new base. Should we calculate that? Let's do it. Let's use the calculator to do that. 5 log divided by 2 log. Look right here, log of 5 divided by log of 2. This is exactly what I have as a by fraction. This is equal to 2.3219. And that's my answer, 2.3219. Remember that this is a number with many infinite non-repeated digits. Let's do the following problem right here using the base. Again, now let's do it with ln, right? Let's try it with ln. We'll change base, but the new base will be e. Okay, so this is going to be, what's the denominator? Start with the denominator so you always remember. Remember, the denominator will be the new base, so base e right here, of the old base. And the numerator will be the new base, the new logarithm with the new base of whatever the number I had before is. That will be my answer, ln of 16 divided by ln of 3. How do I calculate that? Well, I change that to ln so I can see it, and I want to calculate ln of 16 divided by ln of 3. The answer is 2.5237. Assume now that you want to calculate this number. Well, what is the old base? 12. What is the new base? You choose. Let me do it with ln. ln of the old base, that is 12. And the numerator will be the new base, ln e, of the number that you want to calculate the logarithm. And you are calculating that, and this will be, in this case, let's do it, 2.5 ln of that divided by ln of 12. 12, first of all you put that, the 12, and then you calculate the ln. The result will be 0.3687. 0.3687. And this will be your answer.